Hello everyone, in this video I am going to explain you about number of equivalent domino pairs. This is today's question. Problem number is 1128. Now the problem says, given a list of dominoes, they have given here list of dominoes, and domino of I is a pair which is also a vector basically, which contains only two elements A and B, is equivalent to domino of other j whose value is C and D, and these two both are equivalent if and only if A is equals to C and B equals to D, or A is equals to D and B equals to C. So they have given here these conditions. Now we need to return a number of such pairs which are equivalent. So let's understand the example. If you see here 1 2, this is a domino pair, and if you see 2 1, and these two are equivalent because in this case A is equals to D and B is equals to C. If you consider these two as AB and these two as CD, so these two are equivalent. And if you see any other pair, we don't find those are equal. And if you see in this example, let's see this one 1 2, this is equivalent to this pair. These two are equal. A is equals to C, B is equals to D. And if you see this one again, so these three can be equivalent to each other. So since there are three pairs, so we can get 3 into 2 divided by 2 pairs. And if you see other pairs 1 and 1, they are not equivalent to any other because we don't find 1 and 1 other time. And if you see 2 and 2, those are also not present. So in this case we have 3 as answer. So the idea here is that, see, if you see the constraints, they are given domino's length is 4 times 10 power 4, and domino's I of length is 2, and domino's value where I and j will be between 1 and 9, both are inclusive. So what we'll do is we'll take 2D vector, and that will be of size 10 cross 10, and we will basically store these two values, like one seems to be ith index and 2 will take it as jth index, and we'll try to store the frequency. In the same way, if you see 2 and 1, these 2 and 1 and 2 are both are equivalent because of this condition they have given. So what we'll do is, while storing first element, we'll store it as lesser element and second as greater element. So in this case we'll swap these two values and store in our frequency vector, 2D vector. So that will be 1 comma 2, and this is also 1 comma 2, so frequency will be stored it as 2. So same thing we'll do over all the dominoes, and then at the end we will iterate through our 10 cross 10 vector, and if we find values greater than 1, first we will initialize our 2D vector with 0, which means we don't have any pair, and while moving through these dominoes we will find some of the pairs, and by the formula frequency into frequency minus 1 by 2, we will get the pair for a particular number of pairs for a particular 1 and 2. So let's do it here. First we will take a 2D vector whose name should be frequency, and we'll initialize with value 10 because here they have said dominoes of I and j will be in between 1 and 9. And we'll initialize it to 0. Now we will iterate through this domino vector, and let's say here I is domino of 0 and j is domino of 1, and we will check here. If I is greater than j, then we'll swap them, which means if you see this particular case, So in this case I will be 2 and j will be 1. So we need to store lesser value first and greater value second, so that a proper pair consistency will be maintained. So if we do this way, so these two will be equivalent, and of course they are equivalent according to the question. So we'll swap ig. Now we will store in this frequency vector frequency of ij plus plus. We'll increase the frequency of this particular by 1. Now we have got all the frequencies from this particular loop. Now let's take our answer as 0 starting, and then now we'll iterate to our frequency vector 10 I plus plus and we will increase our answer by first we'll take this frequency value as val. Int val is equal to frequency of I comma j. So which means for this particular pair what is the frequency, and we will calculate with the formula val star val minus 1 divided by 2, and this will be our frequency, and at the end we'll return our answer. Let's try to run the code. Perfect, is running fine. Now let's submit the code. Yeah, it got submitted. And let's analyze the time complexity of this solution. So if you see here this for loop, it takes domino size, wherein they have given domino sizes 4 into 10 power 4. And if you see this for loop, which is constant 10 into 10, which is 100 times it does run. So time complexity will be domino's length, and space complexity will be, since we are taking constant vector which is of 10 cross 10, which is 100 cell size, so we can treat it as O of 1. So thank you for watching.